Today, I'm going to walk you through a live demonstration of my project, the Citizen Protocol blockchain. This is not a typical blockchain demonstration. What I'm about to show you is something different. A system where data is not just stored on chain, but secured, encrypted, and controlled by the user. This demonstration focuses on one core idea: how an encrypted file together with structured form data can be submitted into public ledger and remain completely private even though the data is on chain. It is not readable by the public. Only two types of entities can be created: the wallet holder who signed the transaction and any explicitly granted readers. Let me first show you my working environment. This is my development workspace where the entire system is built and tested. Everything we're seeing here is part of a single monorepo architecture. Everything yours, where all components lead together in one unified code base. Inside this monorepo, you'll notice two different dominant technology: Rust and TypeScript. Each one has a very specific role in the system. The blockchain itself, under the Citizen Protocol folder, the core protocol is written entirely in Rust. This gives us memory safety, high performance, deterministic execution, strong system level guarantees. This layer handles consensus, ledger state, transaction validation, and cryptographic integrity. Surrounding around this blockchain, all application and interfaces are built using TypeScript, Adapt, Demonstration, Explorer, Landing. This allows rapid development while maintaining structure and reliability. Now, let's focus on one of the most important components, the wallet browser extension. Aside from the main protocol, the node validator, the node runtime, the wallet is very important also. It's vitally important. The wallet browser extension is not a typical wallet. This is a typical wallet. If you look at the browser, open the wallet browser extension. This is not a cryptocurrency wallet. There are no speculative tokens inside. Instead, this is a signer-reader wallet. Its purpose is simple but powerful. It gives consent, it approves transaction, and it unlocks encrypted data from the public ledger. What makes this architecture different is that the separation of responsibility between the builder and the user. The builder application, this one, and the production, this is hosted somewhere remotely on the cloud, while the user wallet stayed on the user's device locally. The application does not control user data. This one cannot control the data over here. The user does. All critical credential and sensitive data remain with the user. So it remains on the wallet browser extension. They are stored locally inside the wallet browser extension. They are never exposed to builder backend. And they are never controlled by the application. So in the future, This wallet browser extension will also exist as a native mobile application, which means that user will carry their identity, keys, access directly on their own phone. But for now, we'll focus on the browser wallet extension version. Now that you understand the architecture, let's move into the core demonstration, um, submitting encrypted data into the blockchain. In this demo, I will fill up the form from this landing page. By the way, the intention for this landing page is for educational purposes, for those who are interested in joining the project. So they need to learn what is citizen protocol all about. So after viewing all the info cards and learn about citizen protocol, they will redirect it into a form, a submission form. Then that submission form ask permission with the user. First, after the form filled in by the user, the builder application will ask the user to sign the whole thing. So the builder app will send the unsigned payload to the wallet on the wallet browser extension. Then uh, the wallet browser extension will sign this one and give it back to the um, builder app with already signed and encrypted. And after that, the builder app submit it into the ledger. Let's see if that will happen with this demonstration. But first, I need you to observe what happened when I close this browser extension. And right now, I'm on the main page of this landing onboarding site. So when I click either of these two buttons, go to onboarding page and start onboarding. If I click this one, it's loading. We expect the wallet browser extension to load it up, and then it will open the wallet browser extension, the side panel. Then you notice from the button, from Wallet Connect, change it to something that public key signer of the wallet holder, and it says that wallet logged in successfully. Your onboarding session is active. So there's a handshake between the builder app and the wallet browser extension. So let's start with the info cards. When I press start, we'll proceed to the info card number 1 and up to info card number 29. The info card is similar to a flashcard, but is a digital version. It's a snippet of information. What is Citizen Protocol all about? You can use your keys on your keyboard, the left and right. When you go forward, go to the next info card, you just press the right key. If you proceed back info cards, you need to press the left key on your keyboard. If you are already familiar with about the Citizen Protocol, you can escape on your keyboard. You can press the escape button on your keyboard. So let's let's click the escape button to proceed with the form. Now I'm on the form. This is the demonstration how the form being filled in and ask the wallet browser to sign it in so let's proceed. First, I choose as a validator, continue, then put it my name, builder 12. Okay, civic do Davao, then email address. This is just a sample. This email address is non-existing. Citizen Dutch base. Then the country is Philippines. And now, the reason why I'm joining, I just want to become a validator. Then I'll choose an attachment. Look for a PDF file as a sample. Okay. Then wait until the attachment loaded on the builder app. So we have this one. So now I want you to observe that this one, signed submission, meaning this unsigned payload, the form and the attachment is converted into a JSON payload. Then this JSON payload will the builder app ask the wallet browser to sign it. Then the wallet browser will encrypt it and sign it and give it back to the builder app. Then the builder app, um, the bottom will change that it's already signed. It need to be processed and submit it to the ledger. So let's see what happened when I click this sign, uh, the JSON payload, asking for the user to sign it. So it says processing, and we wait the wallet browser to react. Then we need to click this automatically to sign the submission. Then give it back to this browser. It says submit sign. So meaning you need to click this one, processing, and ready to submit it into the ledger. Okay. Um, if you can see the commitment receipt hash, meaning the transaction already submitted into the ledger successfully. And on the wallet browser extension, you can that hash has a link going to the Explorer to verify it. So we need to click this one to verify if the transaction is actually or it's truly submitted into the ledger. So this is the blockchain explorer. So this is the commitment hash, the transaction we submitted, and we need to click the entry ID to see which block this submission or this transaction reside. So we need to click this one. It takes time because the computer is very slow, and also uh, this computer running multiple application with five validators and with 4 application, uh, the landing page back end and Explorer back end, the front end of the landing page and the Explorer also running at the same time. So that's reasonable why it's very slow. So now the entry or the transaction submitted at block 61. So we need to see the entire payload, the JSON payload, encrypted payload on the blockchain. So we need to click this one. This is the entirety of all we submitted on that particular transaction. So the very important to notice on the Blockchain Explorer is the reader key wrapper. For this demonstration, because I demonstrate it with the intention that the use case designed for a uh, government use case. So if you can see, we have 3 readers. Why we have 3 readers? Because it's designed for government. So any transaction, uh, uh, there's a certain agency in the government that demand for reading every transaction of that particular agency. Like for example, if this application, this builder app is think about it like it's from LTO, then the LTO is the operative, the builder app or the operation. This is the wallet of the LTO. behind it. So they can read it also. And the second one is the audit. This one is the consortium wallet. They did for the consortium wallet. So I did. So it's not only the owner of the transaction, the wallet holder can read it, but uh, the LTO, the the agency, the consortium wallet can read it also. So for this demo, I will use the secret key of the public key reader to decrypt and read the form into its normal readable form. So what we need on this blockchain explorer is the entire payload, a JSON payload of the blockchain. So the blockchain is actually running this one. This is the endpoint of the blockchain. This is the validator, the runtime. If you're going to right click this one and go proceed, you'll, this is what it looked like on a in a node runtime. The entire thing is it's just string, so you cannot see the form is not readable, the submission is not readable, um, but you can verify that the form exists, that the transaction exists. Okay, now back how to go back to the browser explorer, and we need to copy the entire JSON payload of the submission. So this one, we need to copy this one and go back to the wallet browser extension, go to the decrypt tab and paste it here, the JSON payload. Okay, this entire thing is on the JSON payload. So we need to load the fields that needed to decrypt the file from this string, garbled string, into a readable string. So we need the author public key hex. It can be located on the ledger. The wrapper deck hex can be located in the ledger. The nonce hex can be located in the ledger. The cybertext hex can be located on the ledger. Now, you think that every field needed is already on the blockchain. How can we say that it's safe and that only the wallet holder can read it? Because one important field, or one important key that is not in the public ledger, it's the secret key reader of the wallet holder. This one. Uh, this one is the public key reader, comes with a secret key. So the operator, the builder, has its own secret key to read the payload. The consortium has like secret key to read the payload, and the wallet owner, or the owner of the transaction, uh, has the secret key to read the payload. And that secret key to read the payload is resides on the wallet browser extension. You look at this on the security, and we reveal the credential totally. You can see uh, the secret key reader inside it. This is the public key reader. This one comes with a secret key reader, and you can only find this one at the browser wallet extension. So that's why we need to. That's why browser wallet extension is very important. So sooner or later we develop a mobile app for this one. So we don't only rely on a wallet browser extension, but a mobile app. So let's go back to the decrypt file. We redo everything because uh, we need the payload of the JSON. Copy this payload. Okay, this one. Actually, it's already here. So we need to load again fields. Okay, we have the fields, important fields in decrypt. Now You can see we attach a blockchain.pdf file, so we need to click this one. Okay, save, then click this one. See, you can read this back to its readable form. It's not garbled like what we see on the public blockchain. So it happened because we have the secret key to unlock the file back to its normal form. So if you're going to see also the form, the exact form, this is the attachment, but we need also to check if the form, we can also read the form. So if you go to your wallet browser extension, we choose to become a validator. This is our reason. The institution we belong, full name, okay, full name. I put Green Armor Builder 12. Email address, Green Armor Builder 12 at citizen.space. Country, Philippines. And the attachment payload, blockchain.pdf. And the string, the 64 key hex of string of this PDF as attachment. So that's how citizen protocol all about. The intention is to respect the user. At the same time, we created a transparency, accountability for the government to use. So that's all for this demo. Thank you very much.